Hello, my name is William Lee, and I'm going to explain my delta Wine converter program. This project focuses on delta Wine conversions, which are very common in a circuit analysis, especially when it's used in a three-phase network. The goal in the network is to ask the user to convert between a delta or a Wine network, ask them for an impedance value, and finally convert them into their following function. We start with the program by defining the function getImpedance, which asks the user to enter an impedance value or a complex number. This line over here prints out the message which impedance we're entering in for. It can be either ZA, ZB, or ZC, that is for a Wine function, or Z1, Z2, or Z3, which is a delta conversion. These line right here ask the user to combine both the real number and imagined number at the end of the return value. I use a float integer just in case of the user enter in a decimal number instead of a whole number. We go to our first conversion, which is from delta to Wine function. Over here, the total adds up all three impedance and calculates them into ZA, ZB, and ZC for their Wine units. The next one over here is Wine to delta, which we add up all the total in the common numerator, and that we convert them with the following formula into Z1, Z2, and Z3. These two return functions will go into the main program depending on which conversion the user asks for. Next over there we have a format system, which I define as format complex. This over here will format the final output. It will be put as constant plus j multiplied by a constant, and returns the value to which sign they belong to, depending if it's a positive or negative. Now we start the beginning of the program, which is the main program loop. This loop over here can do multiple conversions. First, I ask the user what conversion they want in which network, delta or Wine. And after that, I ask them delta or Wine. For my first if statement, if the user asks for a delta network, or they ask delta, we'll convert to Wine. So first, I get all three delta impedance or complex numbers from the user. Then I call them to convert them. And finally, I print out the results in the final format. Next over here is my if statement, if they want to convert them from a Wine statement to a delta statement. So first I get three Wine impedance, then I convert them into a Wine I convert them into a delta values, and after that I print them out at the end in these four statements. This else statement is in case that the user types something wrong, will show them an error message. For example, if they put like an alpha, we'll put in invalid input, please type delta or Wine. This program will keep going in a loop until they write in the right system or the right conversion program. As soon as the user asks for one network, for like simple delta, and they get the conversion and they print it out, we'll go to our last line over here, which is line 61, and they will ask them, do they want to run the program again? If they say yes, then the program will keep going in a loop. If the user types in no, the program ends. For example, I run the program. What network are you looking for? I type in delta, and I enter my real part number, which is 1, imaginary. Now Z2, 1, 1, 1, 1. Calculates all of them into a Wine network, and I get my values in ZA, ZB, ZC. Now they ask me, do you want to repeat the process? I will say yes. This time I'm gonna do this in a Wine network. I'm using the same values, which is 1, 1, 1, 1. Let me scroll down a little bit. 1 and 1. Now it's converted into delta network. Now, if I type in no, over here, the program ends and the code execution is successful. So thank you for watching my video on my delta wine converter program. This shows how engineers use a delta wine conversion in the real world of circuit analysis.